In this video, we're going to talk about how we can link our system platform objects automatically to your Allen Bradley user-defined data types in your PLC. If you look at the structure, if we have a user-defined data type in a PLC that looks something like this, where I have some structure, it's a tank 41 with a mixer, which includes a VFD and a couple start stops and a speed sensor, and I also have a level sensor out there. So if we mimic this same structure that we have over here in the Logix processor, and we kind of build objects over here, a complex object that gives you that same structure, we can automatically bind when we make that connection to the PLC. We can automatically fill in those addresses automatically. You know, the way it's done is we have the device integration name, we have something called the scan group, say a program that's in the Logix processor, and then the actual name. So here's what the actual address will equate to when I break that all the way out. So let's take a look at how we configure this automatic addressing. One of the first things we're going to need to do is go into the System Management Console and configure the I/O driver to communicate with my Allen Bradley PLC. So if I drill down into the Operations Integration Server and drill down even further, you're going to see the Allen Bradley CIP drivers here. The Operations Integration Servers are the new generation servers from Wonderware. You can see I have multiple instances of this ABCIP driver if I'd like. But I'm going to drill into this first one, drill down the configuration, and one of the first things I'm going to see is this port object, and I'm going to take the default there of 4 messages. I'm going to drill down into this parameter here. This is going to point to the IP address of that processor out there. I'm going to drill into the configuration of a backplane. I need a backplane to point to. And then I'm going to actually look at the processor. This is a compact Logix processor. I'm going to take some of the defaults of where the actual processor is, optimize for read. But one of the main things I need to do in this setting is set the device group. So right now I'm going to define a device group, in this case called drying. I'm going to simulate a drying area and how often I want to go extract that information from the PLC. This is the pull time. I'm going to go out and pull that PLC every second to extract that information. So now we're going to take a look inside the IDE of what needs to be configured inside there to be able to communicate with this PLC. One of the first things I'm going to need to do is configure this DDE SuiteLink object. This is an object that's going to link to that DA server that we were just looking at. So I have this DDE SuiteLink object called ABOI1. This was derived from this DDE SuiteLink object, which was a master object from Wonderware. It's used to point to I/O servers. So if I drill down into this object, I can see the configuration there. So this is where I actually pointed to the ABCIP. This matches the name that we had inside the System Management Console for the OI server. I'm going to leave the server node blank here because I'm working on the same machine. If I was pointing that to a different server somewhere else, I will put in that other server name. The communication protocol is going to be SuiteLink, which is our Wonderware communication protocol, how we're going to communicate between this object and that driver. And then the other thing we need to put in here is a topic, right? This topic is going to point to that drying topic. If you remember, we defined that inside the OI integration server. Scan mode, I'm going to set this to active, so it's going to go out and pull that data all the time. So now that we have the communications links configured, we need to look at an object, and the object's going to have the I/O definitions to be able to point to I/O directly in that Logix processor. So if I look at this tank system here, it's a little template that I have here. It's going to have some attributes. Those attributes match what I have in that Logix processor. So the syntax I have here for the auto, command, LITO1PV, the transfer pumps, the valves, this exact syntax, these variables, as they look here, are defined in that Logix processor. So that's the beauty of this. If I define a parameter or an attribute in the Wonderware side, it's going to match what I have in the Allen Bradley Logix side, and I can automatically link those two things together without having to type in any addressing. So, you know, if I look at this level transmitter, one thing I'm going to need to do is make sure the I/O is checked here, and you can see it's going to default to a variable, right? It's going to default I/O device my tank sys LITO1PV. So that's the default variable it's going to go try to get. It's going to replace my tank sys with the instance that I make, and the I/O device is going to point to the I/O device that we just created, this ABOI1. So basically, you know, I define my object, I define that all those going to have I/O, I check that I/O box. You know, if I do have historization or things like that, I can check that also. So now I have my template defined. Now I can start making instances and link them to my ABIO. So I have this my tank system here. I'm going to make a new instance, putting it in my drying area, which is my default. I'm going to point that to tank 010 is a name that I have in my Logix processor. So it's a user-defined data type in my Logix processor that I'm going to link to. I'm going to make another instance of that, tank 020, and I'll make one more new instance, 030. So if you look at those instances I just made, you can see there's a little exclamation point, and that's telling me there's a problem. And if I look at the errors and warnings on that, it's going to say, hey, these guys aren't assigned yet. These IO references that we're pointing to haven't been pointing to a PLC, so it doesn't know what to do with those. So it's kind of giving you a little warning there. So the way we resolve those warnings is we basically take these objects and we drag them over to this area. So that we defined this ABA01 previously, and we defined a topic called drying. So this is how we make the link between the drying PLC that we've defined in the OI server to this object. So I can literally select these three objects, and I'm going to take those, I'm going to drag them and stick them underneath that drying PLC. And if I drill down to that, the errors went away. The exclamation point went away, and now they are valid references there. So now I have these tank systems pointing to this drying PLC out here. Now I can do some validation to make sure that I do have valid references, and it's going to validate correctly at the PLC level. So I have this other view that I can turn on. I have this IO device mapping view, which is a way I can go click on one of these tank systems, tank 010, and these are the actual addresses that got filled in for me. So this is the auto addressing that took place, because I have my naming conventions mapping the control Logix data structure. This is what it's going to link to. So I have the ability to look at these IO addresses, and I have this validation button. What it's going to do is actually going to go out and connect to that PLC and tell you if you have a valid reference. So in this case, I do. It went out and passed, and it found these variables inside that control Logix PLC and told me they were good. If there was a problem, it would show that. So I can go pick these other tank systems. Now here's tank 020. I can do a validation on that one just to make sure that it's going to have these variables inside the PLC. And if you can see, if I can click on that, that value is moving, right? That value will change. So it's live data coming up from the PLC. Tank 030, we're going to validate that. The interesting point about this, these objects have not been defined yet or deployed yet. So these objects are, they've been defined, but they have not been deployed. So they're not truly running in the system platform environment, but we are going out and pulling the IO just to make sure we have valid references. So once I have those references all validated, I need to deploy those in system platform to bring them online and start collecting data from that PLC. So I'm going to deploy these three objects that we created, bring them online. So it's going to go out, it's going to connect to those OI servers, pull the data back in, have a little object viewer running right now. It's telling me my data is bad, it hasn't caught up yet. So once that data catches up and the objects become good, I should see data coming in from those PLCs. So right now I'm looking at one of the discrete bits. I'm also looking at one of the level transmitters. Okay, so they just went good, so it has a good connection. These objects are connected to the PLC. You can see I have data moving from each one of these level transmitters. So, that's the beauty of the auto addressing, the ability to kind of just very quickly make an instance of an object, drag it over to the PLC, and start collecting data very quickly. So I'll do it one more time here. So if I go to my tank system, I have a new instance. I'm going to make a TANK040, rename that object, take that guy, I'm going to drag him over to my drying PLC. He has a good valid reference. I'm going to deploy him. I'm going to look in Object Viewer. You can see tank 040 is there now. I'm going to take this level transmitter from tank 040, stick it into my Object Viewer here. It's initializing, and I have good data coming up from tank 040. So very quickly, I can create templates, create some objects, drag them over to my IO server, and not have to worry about all the addressing. The key is that I have to match, right? The IO has to match what I have in my PLC. So I'm going to make my object look very much like the IO I defined in my PLC. So that's the key right there, is when you're defining those user-defined data structures in your PLC and you're defining your templates and your objects, those variables need to match. The naming structure needs to be the same, so I can very easily drag and drop that data over to my PLC objects and automatically link up. You know, one thing I hear from some of customers saying, hey, well, Rockwell, we can browse down into the PLC and pick tags. I think this is easier than picking tags. We don't need to pick tags. We just make a new instance. We automatically link to those variables in the control logics processors without having to browse for every variable and pick and choose. It does it for us automatically. So I think the ease of use is great here, where I can just drag and drop things and point to my PLC, and I automatically bind that IO to the PLC. So let's take a look back at the configuration of the OI servers where we started this video, and drill down and look at the diagnostics. Now we have data being pulled from the PLC. We can drill down and look at the actual data coming in from the PLC down at the IO server level. So you can see here all the variables we're asking, tank 010 and tank 030, 040, and all the variables that we defined in those templates. This is showing you that this data is truly coming back from the PLC. It's got a good quality, data is moving. So a great diagnostic tool and a great troubleshooting tool. If you're not getting data in from your PLC, you can go into the system management console, go into the diagnostics of the OI server or the DA server, and you can see the actual values coming in from the PLC. You can see some statistics there. It's telling us that we're getting 40 variables coming in from the PLC. We don't have any errors this time, so it's a great way to go look and see and validate that you are getting data up from your PLC. Well, thank you for watching today.
Need to learn more about this and other InSource products? Check out our training tracks designed to guide you down your learning path for InSource products. Whether you're using a classic InTouch and Historian architecture or using System Platform, we have a track to help you get the most out of your software investment. To register or learn more, click the link in the video description below. Thanks for watching this InSource video.